In this video, we will discuss finding segment lengths in circles using chords, tangents, and secants. Now first, let's discuss the theorems and then we'll summarize with a table like we did for the angles video. For a given point and circle, the product of the lengths of two segments from the point to the circle is constant along any line through the point. So the first example is an illustration of a situation where the lines intersect inside the circle, and we'll see that our calculation is the little part of A. So notice A and B are on the same line. So it's A times B equals, again along the same line, we have C and D. And it's C times D. So a way of thinking of this is it's the little times the little of each segment. So little times little. Now when the lines intersect outside, we see we have a different type of relationship where we have the whole length, which if we were to add this would be W plus X times the part outside, so times just W, equals the whole length for the other part, which would be this whole segment, so it'd be Y plus Z times just the part outside, which is just Y. So this can be thought of as the whole times the part outside the circle. Now the last example, the lines intersect outside, but this is a special case where one of the lines, T, is a tangent to the circle. Now, if we were to calculate this, the length of the whole thing is T times the part outside is T, making it so it's just T squared. So when you have a tangent, it's the tangent squared. The other part is the exact same as it normally would be. Now, to summarize the segment relationships, first let's review what we have for our different properties. So we have when the lines intersect inside the circle, as shown, we're multiplying the little part of one line times the little of the other. So A times B, noticing they're on the same segment, equals the little part C times the little part D. And again, essentially this theorem is telling us that we should multiply the little part times the little part. For the part outside the circle, we would have to multiply the whole thing, which in this case, the length of this whole segment would be X plus W times the length of the part outside, which is just W. So X plus W times W, and for the other, it's the same thing. So the length of the whole thing would be Z plus Y times the part outside, which is Y. So it's Z plus Y times Y. So essentially, it's the full times the little outside. And lastly, for our special case with tangents, and we have something where it's a tangent, where it's only outside the figure, it would be the tangent times the tangent, which is the tangent squared, and the second part is the exact same as it was for the other outside the circle relationship. And again, like we talked about the angles, I would highly recommend writing this down in your notebooks or taking a picture of it so you have it to refer back to. Now in the first example, we have to identify where the segments intersect. So if we look, the segments in this case intersect inside the circle. Now the formula we use when they intersect inside the circle is the little times the little. So if I'm looking at the first segment, I could say one of the little segments is x. So x times another one of the little segments is the 5. So x times 5 equals, for the other half, one of the little segments is the 3. So it's 3 times the other half of the little segment is the 7. So it becomes 3 times 7. Now if I solve, x times 5 is the same as 5x. 3 times 7 is 21. So you could divide both sides by 5 to get your answer of x equals 4.2. Now in the next example, the lines intersect outside the circle, which means it's the full thing. So the full times the little part outside. So if I were to determine that, the full thing for this segment would be 6 plus 8, which gives us a value of 14. So this whole length is 14 times the little part outside, which is 6. So 14 times 6 equals, for the other, the full length is this whole figure, which we can't add, it's just 7 plus y. So it'll be 7 plus y times the little part outside, which we could identify as just 7. So now if I want to simplify this to solve, 14 times 6 gives you a value of 84. You can rewrite the 7 plus y times 7 as 7 times 7 plus y. Distribute the 7, so you get 84 equals 49 plus 7y. Subtract the 49 from both sides, so you get 35 equals 7y. And divide both sides by 7, so you get 5 is the value of y. For the next example, we have the lines intersect outside the circle, which means we use the full times the little part outside. So if I were to do this for the first part, the length of the full would be 8 plus y, which we can't simplify. So it's 8 plus y times the little part outside, which is just 8, which equals, and then we'll see on the other side that this is one of the special cases with tangents, because 15 is a tangent. Remember, when we have a tangent, we use the tangent squared. Because if we think about it, the full part of the tangent is 15 times the part outside, which is just 15. So I can really rewrite this as 8 plus y times 8 equals 15 squared. Now instead of writing as 8 plus y times 8, write as 8 times 8 plus y. 15 squared gives us a value of 225. If I distribute the 8, it gives you 64 plus 8y equals 225. Subtract the 64 from both sides, to give you that 8y equals 161, and divide both sides by 8, so you get that y equals 20.125. Now in this type of example, we're using another situation where the lines intersect outside. So the relationship we use is the full times the little part outside. So if I identify the full here, it'll be this whole length. We know that 16 plus 8 equals 24. So it'll be 24 times the part outside, which is just the 8. So it'll be 24 times 8 equals the other side of our line, which if we look is one of those special cases where we have a tangent. And remember the special case with tangents is it's really just the tangent squared. So in this case, the other side would be z squared. Now if I want to solve, I can multiply 24 times 8, which gives you a value of 192 equals z squared. And then to finish solving, you have to take the square root of both sides. So if you take the square root, it gives you a value of 13.86 equals z. In our last example, we have to first determine that the lines intersect inside the circle, so it's the little times the little part. So if I were to use that, one part is x plus 10, so I could say I have x plus 10 times the other little part, which is just x, equals, for the other line, one little part is x plus 1. So I have x plus 1 times the other little part, which is x plus 8. So now in order to finish solving, you would have to distribute or FOIL both sides. So if I multiply on the left, I can multiply the x times x, gives me x squared, and x times 10 gives you 10x. On the right, we have to FOIL. So x times x becomes x squared, x times 8x becomes 8x, 1 times x becomes plus 1x, and 1 times 8 is plus 8. Now if I simplify, I get x squared plus 10x equals x squared plus 9x plus 8. Now the first thing we need to do is move all the x squareds to one side. So if I subtract x squared from both sides, the x squareds cancel, so we get 10x equals 9x plus 8. Now the x squareds cancel, so it's just a traditional equation. So if I bring all my x's to the left, I'd subtract 9x from both sides, which would give me just x equals 8, which is your final answer.